Okay, third video. We will finish up what we need for everybody's schematic. And then we'll start adding the stuff that I want for my board. And you will likely want to diverge and do something for your own. Okay, so right now, we've got a way of programming it. We've got the microprocessor itself here. We've got the crystal, which is 16 megahertz. Oh, I can edit that. Let me jump in here. That's always been in my way. So let me just, let me see here. Value, that should be 16 megahertz. Okay, let's see what that does. Oh, it makes the label much smaller. Okay, so now I can move. No, if you start doing that and it's moving the wrong thing, you know, you can, if you've already clicked it down, you can Control Z, Command Z to back it up, or hit Escape. Okay, so here's my label. So I can just put this someplace where it'll be out of the way. And then the Y, same thing. This is going to say Y1 eventually, and I'll just put it down here. Again, just trying to keep it out of the way. Okay, so now I've got my crystal in. I've got the LED that you have to have, and everything's ready to go. We should probably add a capacitor between power and ground. It's, you know, it's bypass cap. You really should have one, and it should be 100 nanofarad. Oh, and this 22 picofarad over here, that should have really been 100 nanofarad. So let me come in here and fix that. 0.1 micro, 100 nano, whatever way you want to say it. Okay, so there's 100 nanofarad. So I want another one of those someplace. Well, you know, now that I've got it, I'm just going to come on with a mouse and Command D, make another copy. And, you know, I've got power and ground right there next to each other. So if I just stick this sucker up here, I can put lines on it. Let me just do that. Okay, so now we've got a cap there. So next up, what we want to add is the USB interface, and that's a little bit, it's really a serial interface. We use the UART on the ATmega 328, and then we use a USB to serial converter, which is that CH340 chip that we'll have to add on here. I hope it's in there. I haven't even looked to see if it's in the data set yet. Okay. So let me take the two serial data lines are actually on PD0 and PD1. They're right here. And we're going to run those. Well, you're just going to put flags on them right now. So this one's going to be TXD. And I'm just going to put it right there. And then I want RXD. And I'm going to put that one right there. And I'll hit an escape key so it goes there. Let me draw the lines in. Okay, so now when an Arduino first powers up and comes out of reboot, it takes about a half a second and it looks to see if somebody's trying to talk to it through the serial interface. And if nobody attempts that, then it just goes ahead and executes the program that's already loaded. If somebody sends in the right characters, then it goes into bootloader mode and allows somebody to download a new program for it. So that's kind of how that all works. And that's what the Arduino software does on your computer, is it tells it to reset and does those things. So we need to put that whole circuitry on this toy. So, okay, let me go back and see if I can find a connector USB. And we're going to use a micro USB. Footprints. Now I got to figure out which footprint we want. I think it's this one. Yeah, that looks right. This is the Molex 47346. And I'm going to say OK. So here's my USB micro connector. And really nothing goes to the left of it. So I want to put it clear over here because I need room for stuff. And I want to put it, yeah, we'll put it right here. Now, we need a ground. So let me hit the escape key because I can see some stuff's wrong. Let me come here and grab a copy of that. Put that over there. I need, there's a 5 volt. This V-bus is the 5 volts coming from your computer. You do not want something going back into your computer. It should be the 5 volts coming out only. So we want to put a diode in line. But the problem with the diode is it's got a voltage drop. So we put a special diode in there. We put a Schottky diode in there. And a Schottky diode, that's specific ones. I want just a, there's a D Schottky right there. Okay. That's what they look like. Footprint. This one's a little bit bigger, and it's going to be actually a 1206. That's the one I've already got. So it's just a slight bit bigger than the resistors and caps we've got. So I'll just select it here so I don't have to later. And it actually goes the other direction. So I'm going to hit the R key twice to turn it around. And I'm going to put this up just a little higher because I already know what's going to happen next. Okay, so then let me wire this in. So this side is actually the side that goes to plus 5 volts. So what I need to do is come back up here. I'm going to hit I keep hitting the escape key. That seems to help a lot when I get things not working the way I want. So I want my 5 volts. I need that to go here. And then I need to get that other part, that CH340, USB to serial adapter. Okay, so let me click on here. And who knows where that'll be. So let me just say CH340. And then I've got a few different options. I think it is the C version that we want. I'm looking at the pin numbers to make sure they match everything that I'd like. It's already got an SO package. That is exactly the right one already selected for me. So let me just grab that. So here's that. So I want to put this pretty low because I only need the ground below it. So now I can zoom back in a little bit. And let's see. We got ground, shield. Those both go to ground. And I got a ground over here. So if I just take this ground, let me hit the escape again, then move. And I'm just going to do that. And then I'm going to connect everything to that. Ground. Okay. So there's my grounds. Now I've got the D plus and the D minus. Those just go straight across. We've got a bunch of unused pins. The pin 15 doesn't actually get used for this, so let me just go ahead and flag it as that. So I did get this X up here and put that on there. And there are other pins that we don't use. A lot of them, in fact. We don't use the CTS. The DSR doesn't get used. The RI stands for ring indicator. That doesn't get used. The DCD, data carrier detect, that doesn't get used. And the request to send doesn't get used. Okay. Let me hit the escape key to get that out of there. So the DTR line, and let's see here. The DTR line is actually the signal that we use to force a reset. But it's actually fed through a 100 nanofarad cap. So I need a 100 nanofarad cap. So let me hit the escape. Let me just reach up here and grab this guy. And let me just rotate it once. And I'm just going to put it in line with the DTR. And then the other side of this goes to reset. So I just need to come up, now the escape key again, and come up here with the Command D. I want the reset, and put it down here. And then we want to zoom in. Let me put in those lines. Okay, I've still got a couple more power lines above. I've got the VCC, and I've got this V3. Now the V3, this thing actually has a 3-volt regulator in it, and it really should have its own bypass cap to ground. So what I want to do is I want to come back in here. I'll hit the escape key again, and then I'm going to make a copy of this capacitor because it really needs one of those to ground. And I'm going to put it here like this. That's actually a bad place because this label and the Schottky diode are going to get in my way. I may want to move that stuff. Let me just, let me move this here. Move, okay. Rotate, that's a ground right there. Let me just take it this way. And now I can come in and wire this guy up. Let me just wire the one side to ground. And the other side goes to the V3. It doesn't need to go anywhere else. My Schottky's in a funky spot. Let me start moving, hit the escape key to get that out. Let me move this 5 volts up over here. Let me move this diode to there. Let me put my mouse on that piece and type a D for delete. And now I can come up here like this. Oops, I want to come through there. Okay, so the only 2 pins left on this guy are the TXD, RXD. So let me go get those. So I want these. Escape key. I'm keep hitting the escape key, which is what I need to do here. There's the TXD, so I'll just drop this over here. Hit the escape, Command D for the RXD, and that should be RXD. And if I get it right about the right spot, then I can. Okay. Move. Oop. Move. Now, if you look on the data sheet for an ATmega 328, you'll notice that pin 30 is not the transmit line for the serial, it's the receive. But that makes sense because the transmit line for the CH340 has to go to the receive line for the ATmega 328. So that's kind of the way it goes. Okay, so now we've got, let's see. I think we've got everything. Oh, we're not quite done yet. That's not quite right. Let me fix this. These don't go straight to here. Let me slide them out. I did this before last semester. I need some 1K resistors and I need some LEDs. These are the lights that blink when you're doing something. And it's going to be an LED and a 1K resistor. So let me just zoom out far enough to get to this guy and duplicate. And I'll put it down here. Escape. Duplicate. Put it down here. Okay. So what I need is 2 resistors in line. In fact, I'm going to delete those 2 guys. And I need resistors in line. So let me move this guy. And I want it pretty close because that's the only thing that goes on this side. Duplicate. Now the labels are in really bad spots. So let me move those. That's the R. There's the 1K. Like that. Okay, so now these go on through. although we're not done yet. Okay, so now I need two more. I need another LED. Let me move this one to a better spot though. Let me hit the escape key first. Move. And then I also want to duplicate it. And I want another one. But these labels again. Hit the escape key. Move. Move. Notice that when I'm moving this label around, it draws a line to the part. Sometimes it's hard to remember which one's which. Okay, a couple of traces. I need one of these to go to this one, and I need one to this one. And now I need a couple of the 1K resistors on top of that. So I'm just going to come back here and duplicate the resistor. I'll rotate it because it'll fit better. And then I'm going to duplicate it again. If I rotate it, it'll put it on the other side for me. That's good. So those are the resistors. And now that has to all connect to +5. Well, I've already got +5 over here, so we can just run that around. Okay. Okay. So there is our basic schematic. This is everything we need. Now, the resistors and caps and stuff are not labeled yet. So we need to fix that. Up here on the top, let's see what we got. Symbols, create, edit. There should be one for, oh, there we go. This one says, fill in schematic symbol reference designators. Okay, which I believe will do what we need. Entire schematic, keep existing notations. Well, none of them are notated, so it'll be sort by symbols by X position. Use first free number after 0. Okay, so you can actually say that you want all the resistors to be like R100 starting. You know, you see that on some designs. Okay. It says that and close. So now when I zoom in and look at here, yeah, here's R1, R2, R3, R4, D1 or D2, D3. There's a diode there. So everything's now labeled. That's Y1. The caps are all numbered. The processor is U2. Okay, I'm going to save my work at this point. You really should save every few minutes just to make sure everything goes smooth. Okay. So this is as far as everybody needs to go. Regardless of what you want to put on your board, you must have this. And if you want to, you know, we've got all these extra pins here that we can connect to whatever it is that we want to do. So the next video, we'll be going through and actually adding stuff to personalize it for my design. You don't want to do that. What you want to do is really difficult. Is decide what you want to put on your design. You could have connectors for servo motors. You could have connectors for external LEDs. They've got neopixels. You've got rangefinders. You know, there's so many things that you can put on here. Don't limit yourself to what I am doing. We can do just about anything. Okay, so that's a good place to stop this video.